Hello and welcome again to my channel. Today we are going to solve another question. This time we are going to solve question number 948, which is marked medium. First, let's understand what we need to do in the question. So the question states that we are given two things, an array of tokens and an integer called power. We can do two things. Either we can increase power using the tokens, or we can increase another variable called score, which we will take on our own. It is not given in the question itself, right? The question wants us to maximize the score, right? It has nothing to do with power. Our answer will depend on the score and we need to maximize it. Now, how do we get a score? We increase the score by 1 when we lose power, the same amount of power as the tokens. Let me explain it a bit more. Say I am in index I, right? So the tokens of I is 100 and my power is 200. If I decrease my power by 100, which is the value of tokens of I, right? If I say I make this 200 uh, 100, that is reduce the power by the amount of the ith index of tokens, right? We can increase the score by 1, right? So 0 will become 1, similarly 1 will become 2 and so on, right? So what happens when power does not have enough value as of the tokens? We can increase the power. Then how do we increase the power? We can say I have moved to this index, right? We can then increase the power, which is 100. We can make it 100 plus 200 300 by losing one score, right? So the score would then become again 0. We will lose the score by 1. So that is the process, right? If we lose power, we increase the score. If we lose score, we can increase the power. Now what the question wants us to do is maximize the score. We are going to solve this problem greedily using the greedy approach as well as the two pointer approach, right? So where does the second pointer comes in? We'll get there. But our approach would be to maximize score whenever possible, because that's what the question wants us to do. The question just needs a score that is like the maximum score, right? That will be our answer. So whenever it is possible, we'll reduce the power and increase the score, right? What about the vice versa situation? When we need to, when we can't increase the score and we don't have enough power, we need to increase the power, right, by reducing a score. So whenever we will reduce a score, what we did in this case is we increase the power by 200. 100 becomes 300 because we used this power, right? 200, and we lost one score, 1 unit of score, right? But what we can actually do is when we lose 1 unit of score, instead of getting a smaller power, we can get the larger power, right? Because it does not matter which power we get, we can get any power from the tokens array given we lose one of the score, 1 unit of score, right? So instead of taking 200, which is a lower value, I'll obviously take 400, which is a greater value. So let's use that approach and solve this problem. Let's dry run this. um, okay, so initially I is here. As I said, we'll take another pointer, which is j. Why? Because as I said earlier, we need the highest power, and we'll of course sort the token so that I points to the lowest value of the tokens and j points to the highest value of the tokens, right? So what we'll do is we'll check I, that is power greater than the ith index. It is. If it is, will lose the power. So power becomes 100 and will move I, and of course will also increase the score. So score becomes 1, right? In the next ith index, we see that power is less than the lowest index available, right? Because we have already used up this one, right? So the lowest value token is 200 and our power is 100, which is lower than that. So we of course cannot increase the score. So in this case, we need to decrease the score by 1 and increase our power. But the power that we'll take is not from the ith index but from the jth index. So that means this will become 0 because we lost one power, and this will become 100 plus 400, so 500, because we took the jth index and we'll move j backwards, right? We used this one. This is the current state. Meanwhile, we'll take another variable called max score, which stores the maximum score that we have seen so far. So far the maximum score we have seen is 1, which was this one, right? Now we have 500 and ith index is pointing to 200. So we can of course use that to increase our power. So 500 becomes 300. By losing 200, we move I forward and we increase power by 1. So 1. Max score remains same because 1 and 1, maximum is 1 itself. Then we check again, power is 300 and ith index is pointing to 300. So we'll lose that. We'll move I forward and we'll also increase the score by 1. That means 2. And the maximum score will also be now 2. Now at this point, we have already used up 400. So we cannot, so ith index is pointing to 400, but we have already used up 400, right? So we'll break at this point, and the condition of breaking will be j less than I, right? J less than I. We will not run a loop at that point. So our final answer is 2, which is correct for this input. So that was the logic of solving this question. Let's now write the code for this. So let's just take the length first, length of tokens, the 2 pointers I and j pointing to 0 and n minus 1, max score, which initially will be 0 because the score initially is 0 itself. Then we'll run a loop for I less than equal to j, because if you remember, we had a state where I and j were equal and we still ran the loop. The code was still running. So it will only break when the I becomes greater than j. So that's why in this loop, I should be less than equal to j for the loop to be running, right? Then we'll check if current power is less than equal to tokens of, actually greater than equal to, right? Greater than equal to tokens of I. If power is greater, we'll lose the power. So power becomes power minus power equal to power minus tokens of I. Will move I forward, will increase score by 1. Else if power else if score is greater than equal to 1, right? Because if this condition is not running, that means power is definitely lower than token, so we need to increase the power. But before increasing the power also, we need to check if score is greater than equal to 1, because if score becomes 0, we cannot reduce the score and hence we cannot increase the power. We have to break at that point, right? So if score is greater than 1, we'll reduce score by 1, increase power by tokens of j and reduce j by 1, else we'll just return max score. If we can't do anything, we cannot decrease the power to increase the score, and we cannot decrease the score to increase the power. If we cannot do both, we'll just return the max score, whatever we have stored up to that point. And of course, after the loop, we'll return max score. Actually, also here we need to update max score as well. Max of max score comma score. We are not updating the max score in this block because in this point score is all decreasing, so it makes no sense to check if it is greater than the maximum score. It will obviously not be greater than the maximum score. The only block where score has a chance of becoming greater than maximum score is in this block where it is increasing, right? So let's run this code. Undefined, okay, we need to define score as well, correct? Score equal to 0. ah, okay, we have missed an important step here, which was to um, sort the array. If you can see, this input is working fine because it is already sorted, pre-sorted, but this one was not sorted, so hence we got a wrong answer. So we need to sort the array. So I'll use a inbuilt function of Golang tokens, and now it should work. Let's submit it, and it is accepted. And this is the whole code. If you want to copy and write it on your own, I hope you understand the logic. It was pretty fair, simple logic. We are trying to maximize the score whenever possible. If not, we'll increase the power with the maximum token value that we can find, because we are losing a score, so we want the power to increase at its maximum possibility, right? um, that's all for today. Thank you, and please subscribe if you find anything helpful. See you in the next one.